Hey everyone, Morgan here. So we are talking about electron configuration and how it affects reactivity and periodicity. Before you view these pages, you should go on to Khan Academy and look at the videos that are posted there about how to do electron configuration, which was something from our last unit. Now, if we're looking at group number 1, it turns out they all have a very similar configuration. Hydrogen's a 1s1, lithium is a 1s2, 2s1, sodium is a 1s2, 2s2, 2p6, 3s1. So all of these are what we could call ns1, meaning the outermost electron configuration for anything in group 1 will be s with 1 electron in it. Now beryllium, 1s2, 2s2, magnesium 1s2, 2s2, 2p6, 3s2, calcium 1s2, 2s2, 2p6, 3s2, okay, 3p6, 4s2. So these are all ns2s. Halogens, you're going to see the same thing when we look there. 1s2, 2s2, 2p5, 1s2, 2s2, 2p6, 3s2, 3p5, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and finally a 4p5. So these are all ns2, np5. And now for the noble gases, they're full. 1s2, 1s2, 2s2, 2p6, 1s2, 2s2, 2p6, 3s2, 3p6. All of these have the same outermost electron configuration. And that's a really important idea. Okay? Now, when we go on to page number 5, we look at the periodic table, we realize that all of the table is structured on these electron configurations. And that's shown really nicely here in all the yellow ones. You see these are all the D's, the red ones are all the S's, etc., etc. Okay? Now, when we're looking at ions and their electron configuration, you have to realize a positive charge means you've lost some electrons. So you have something like 1s2, 2s2, 2p6, and you'd normally think that should be a 3s1, but since you've lost an electron, it's 2p6. In fact, when you look at all of these are all going to be noble gases electronically. Not chemically, but electronically. And it turns out every single one of these ions has the exact same electron configuration. When ions form, they form to have a specific electron configuration that is the same as a noble gases. Okay, enough about electron configuration. All right, so we just said this, to form the same configuration as a noble gas. Okay. Now, the term isoelectronic means that. It means same electron configuration. And in fact, if we wanted to find elements, well, ions specifically, that are isoelectronic with argon, Cl minus, S2 minus, P3 minus, K plus, Ca2 plus, Sc3 plus, Si4 minus would all fit that. Okay. Now, let's go on to something that's much more interesting. Let's talk about the different families in the periodic table. And this was the point of the lab that you did last week, the periodic videos lab. Group number 1 has the old name of alkali metal. And group 2, alkaline earth. Metals. Now this center section right here we'd refer to as the transition metals. Way over here, group 18, we'd call the noble gases. This is the halogens. Now, that would be the element oxygen, this would be nitrogen, that would be carbon, this would be boron. Typically, we would just call this the boron family, the carbon family, the nitrogen family, the oxygen family. Okay. Down here, this is the lanthanides. And this is the actinides. So typically, what we say is up here, these are your main group. And these down here are your rare earths. Kind of general names. Now, property-wise, within a family, what we end up seeing are some pretty similar things. Not always. Alkali metals. Gray, soft, shiny, very reactive. You got that out of the lab. Alkaline earths are shiny, soft, malleable, pretty reactive, not quite as reactive. Okay. Transition metals. Ooh, colorful. And really variable. Oxygen family, there's not a whole lot in there that you really see that's all that similar between them. The halogens are really interesting because you have a solid, a liquid, and a gas all in the same family. And colorful. Colorful. Okay. The noble gases are all the same. Clear, colorless, and odorless. Now, the lanthanides and the actinides, which we know as the rare earths, we're not going to really deal with those very much. Mostly they're man-made. So we don't have enough of them around really to talk about their properties. Now, anything that comes after uranium, okay, after number 92 is man-made. Okay, so those will be a very different situation. And they're just all radioactive. We really don't talk about their properties so much in this class. Okay, so that's it for this video. And in our next one, we're going to be looking at the periodic properties. This is Morgan, signing off.